Okay, so now let's fit a linear model to a set of points in 3D space. To a set of to a point cloud in 3D space. Parameters for plotting, okay, let's keep those, that's fine, although maybe we don't need lines this time, I suspect. Okay, simulate some data. First, x coordinates. X coordinates, so x1. Oh, let's make some kind of a little bit systematic. So let's have here and then we need some y points, x vec t to x. So we have x's. Then let's do y coordinates. Let's change also here x to y. Okay, I think I screwed up something, but let's see. Y coordinates here. Let's see how this would work. I'm not at all sure what I'm doing right now, but we'll take a look very soon anyways. And m, let's change m actually to be the z coordinate. Sorry, yeah. Okay, so what we have here, we have some x points, some y coordinates, and then some z values. So let's take a look how these points are located in 3D space. So now actually we need to use the command plot3, which will plot stuff in 3D space. And let me think. Yeah, I think it should work like this. Let's see what happens. Okay, well, we seem to have some points in 3D space. It's hard to see the coordinates. Let's actually make them a bit more visible. We do have already the font size here, but here we could put, should be axis. Set current axis, let's say x tick. I don't know. Let's say from 0 to 5 and then font size. And maybe let's put, yeah, okay. Okay, here we have the points. It's kind of a bit hard to see because the Z coordinate, oh, they're still too small, these. Let's close that one and let's put the font size to be bigger. And what's our Z point? Z points are, let's put them all kind of 1 point something. And then let's put here let's put axis min xvec max xvec. So I'm giving the bounding box locations for our plot, min and max values for all coordinates, and for z, because we put now the z values between 1 and 2. So let's put here 1 and 2 as minimal and maximal z values. And let's run this thing. So now we have a few points here in 3D space. Not too many. We could have maybe even a bit more. Or maybe let's just put in the system matrix. This time we should have here, let me just do this a bit quicker this way. So we actually have, the vertical x vector as the first column, vertical y vector the second column, and then the third one is just 1, the same size than xvec. So that's our A matrix. This should be zvec, I think. And then, so we use the model z coordinate equals ax plus by plus c. So then we solve, but now plot the model, and now actually we should use mesh, and actually we need not t-plot, but we need a two-dimensional set of points for plotting a function of two variables. So how that's made, let's see, what was our range of x and y. So x and y go from 1 to 3. So maybe let's go from 0 to 4 with our. So here, this is how it's done. We take a matrix of x coordinate, matrix of y coordinates. I use the command mesh grid. Mesh grid, and actually let's just take from 0 to 4. Let me show you what this does, this mesh grid thingy. Let's copy it. I'll just show what happens when we run it. So you see the X is a matrix where horizontally the coordinates are growing and vertically they are constant, just as an X coordinate should be. And the Y matrix has horizontally constant values and grows. It's a little bit weird MATLAB style that it grows when going down, but let's just accept it as it is. So now we have matrices of X and Y coordinates, and we can use the command mesh to plot a 2D of a function of two variables. So this Z to be plot is A times X matrix plus B times Y matrix plus C. And this is just mesh X, Y, Z. Okay, so if we run the whole thing, oh, error, here. Okay. Yes, thank you.
You also put the axis with 3D in the axis. So when you rotate it, it looks much bigger. It doesn't scale this ugly.
Can you repeat? Can I do what?
The axis
To
space bar is 3D.
axis 3D, okay. Here?
Lower, just the last line.
New line, okay.
No, not here. The last page. But
Here?
there. Axis is FBIS.
This way?
Small b and b instead of b. B there.
Visual 3D. Oh, okay.
So when you rotate it, it's
Okay. So here we have a line. Maybe we could have a few more points in our 3D plot function. Where here, mesh grid. Maybe let's take the step size here 0.2, for example. Maybe it looks a bit better. Okay, so here you see that this is now the plane that kind of, in the sense of least squares, is matching these data points optimally, gives the best possible linear fit to these points in 3D. Okay, so that's it for the first part. Next we'll go to Fourier analysis. Let's have a 10-minute break and continue 15 past.